All right, thank you, Sue. Again, my name is Jung, and I am from Virginia University Institute. Well, even though my title said determining the soil modulus for use in soil structure interaction, yes, I know that sounds very complicated, but we are in the manufacturers, suppliers, and with this section, so I'm not going to fall deep in terms of academia. Instead, I will try to answer the question between a very important question, because when I was in academia, I heard a lot of people are actually asking a question that how can we close the gap between the academia and industry? Well, I don't know the answers to that, but I will try to answer that by showing this presentation right over here. But before I start, my major expertise in actually the soil pipe interaction. So pipe is actually going in this way, but some of you may want to ask a question that, okay, well, this is a DFI Foundation Institute, and what are you doing here? Well, if the first answer to that is, well, if I'm trying to switch my expertise a little bit towards to the foundation rather than the pipe. And then the second thing is, if you think about it very carefully, well, this is the pipeline, but if you change the orientation, that's the foundation. Wow. So I'm trying the topics that I'm going to show you is more related with the pipeline, but in the future, hopefully I can use the same strategies that I'm going to explain and then apply this in the foundation. So these are the topics that I'm going to talk about. First thing is the extreme soil pipe interaction. Well, this is the news clip from Korea happening back in 2014. Well, take a look at that. Well, there's a poor taxi driver, but you guys can laugh at it because he didn't, well, his car was damaged, but the person driver did not. He got just minor injuries. So we can just, this is due to the water main break. But this, you can, laugh on it, but this is a little bit different. Let me show you the video of this here. Well, this is the, after the 7.8 magnitude of earthquake in Turkey happened in this year, early this year. And as you can see, this is a serious problem. And we have more than 100 feet of flames, and unfortunately many were killed. So this kind of extreme soil structure interaction, it does matter. And in fact, those kind of extreme soil structure interaction is not just came from the earthquake. It could cause from the hurricanes, the landslide, the tunnelings, the subsidences, and that's not only going to happen in your pipeline, that's also going to have affect the performance of your foundation as well. So how we are going to study this? Well, at least this is what I did. When I was at PhD at Cornell University, well, we performed the large-scale experiment, and we are trying to simulate the earthquake inside the lab so that we can understand the better. As you can see right over here, we do have the lateral movement, and the pipe underneath the ground, they're gonna deform. And then, of course, our interests are underneath the soil, so we may want to perform those kind of tests with the soil, and it's gonna look something like this. So we were going to perform the large-scale experiment, and not only that, that was for the 3D test. We can also perform the 2D test as well. And what I did is, we don't want to just stop at the experiment. We also want to understand how it actually performed, and can we simulate those behavior with the mathematical model. That's where I came in. Well, of course, I'm not going to explain about this kind of right over here. We do have some very weird looking equations right over there. Don't be scared, I'm not going to explain that. But the idea here is we are going to use the numeric analysis or finite element analysis to simulate this kind of experiment. And let me show you this video right over here rather than explain the equation. Take a look at that. Well, as you can see, if I move my pipeline, then obviously my soil right next to me is gonna deform. And the top portion of my soil is gonna heave, and then right next to my pipe, I'm going to have some kind of void. And guess what? My model was strong enough to capture those behavior. And let me show you this one first. And the results are showing up right over here. In this graph, excuse me, the dashed line is the behavior from the large scale experiment, and the solid line is that came from my model. And as you can see, my model and the experiment data, they are agreeing pretty good. That means my model has been validated. And in fact, my topic that I was originally going to explain was this. Well, inside this model, I do have a lot of parameters that I must have to use. And one of the parameters is the soil modulus, or the Young's modulus, if you want to say that. And if you're going to use the classical, the tangent modulus, the initial tangent modulus, I'm telling you, it's not going to represent the reality very well. So what I want to say here in my research was, why don't we use the strain compatible secant modulus rather than the initial tangent modulus, so that it matches better than using the other Young's modulus? That was my original topic. But again, I am not trying to give you too much detail about academia. Instead, I'm going to give you the very broad picture, or the broad result of it. So once my model is validated, that means, well, my model is it's like a virtual box. Once it's validated, I can expand this into any other direction of the pipe movement. For example, here, if at any depths, if my model has been validated through the lateral movement, but if you use this design chart, you can estimate the force that's gonna exerting on the underground structure on any direction. This is what my results are. I think this is my biggest achievement in my study. And as I mentioned earlier, I am trying to answer the question, how can we close the gap between the academia and industry? Well, here's what I did. We did have a major earthquake in New Zealand, in Canterbury. That's a Canterbury earthquake in Christchurch liquefaction. In fact, we do have a multiple earthquake, and the earthquake caused a large liquefaction. That size of the liquefaction is so large that it's almost like a same size of the San Francisco. And to visualize those liquefaction, take a look at that. This entire area is gonna wash out. So if that thing happened, any underground structure underneath it, some structure can survive, but many of them maybe not. And that's gonna depend on the orientation of your underground structure, or maybe the material of it, and when does it installed. So what we did is we used the LiDAR data, and this LiDAR airplane can give us the data for the movement in lateral direction as well as in vertical direction. So once you know those two, we can also calculate the angular distortion as well. And fortunately, we also have the repair rate as well. And here's your key here. This graph is actually showing you that this is a cumulative data of the lateral tensile strain versus the frequency. What is this graph is telling you is, for example, if you're looking for the extents level of 90%, you can just sustain up to 1.5 lateral strain. Let me rephrase this, since this is a MSSP. Say that your product, let's say the foundation, if your foundation can sustain, say, 2% of a lateral strain, that means that 95%, more than 95% of a chances that your foundation is going to be survived. And this is not the experiment. This is from the large, big data that we obtained from the past earthquake history. So I saw one of the presentation in the morning, and they introduced the helical foundation that is approved for the seismic activities. Well, that's good to know. But here, the simple graph like this, which came from the academia, you, the supplier, the industry, can actually use this so that you can claim that your product is going to be strong enough to survive under such extreme event. So this was my answers to the question, how can we close the gap between the industry and academia? So I am trying to do those kind of research for foundation as well. Where at VMI, the Virginia Military Institute, I saw that many of you actually asked a question, what is a VMI is, and they actually made a really good video of it. So instead of giving you my answer, I'm gonna just show you this video.
Welcome to the Virginia Military Institute, where extraordinary individuals like you find their true calling. Here, we are more than just a college. We are a leading senior military college built on strong values and a legacy that has shaped leaders for generations.
At VMI, we uphold the highest standards of honor, guided by our unwavering honor code. It's not just a set of rules, but a way of life, instilling integrity in everything we do.
We are united by the Brother Rat spirit, a bond that transcends friendship. Together, we face challenges head on, pushing each other to become the best versions of ourselves.
VMI is no ordinary college. We create leaders who excel in both civilian professions and military service. About 55% of our graduates commission into the armed services, while the rest go on to graduate school or careers in the public or private sector. 99% of graduates are employed within 6 months of graduation. Our graduates carry the values of honor, excellence, self-discipline, courage, esprit de corps, selfless service, and resilience, forging a path of success in every endeavor they pursue.
Our rigorous academic programs foster a love for lifelong learning, challenging you to push boundaries and explore new frontiers of knowledge. So, are you ready to become part of something extraordinary? Join us at the Virginia Military Institute, where our commitment to excellence will shape you into a leader of character. VMI, never settle for ordinary.
Well, that was the video. Another reason why I came to this conference is I am trying to help my cadets to find a really good internship opportunity. And as you can see, we have a really good companies out there, and I really hope you guys can, advertise their VMI. We are here, and we are also looking for a good internship program as well. So, well, I do have another video, but looks like we are a little bit, well, here's the funny thing. We do have a lot of student activities, and the picture on the bottom right, it looks like, that looks like the rock, the Marine Corps doing something. Well, that's in fact, our cadets are being rescued by the safety when they're having the concrete canoe. And fortunately, we were able to get our cadets safely, but not able to get secured our concrete canoe. So our canoe are still under the lake somewhere. So anyhow, I have another final video that I'd like to show you. This is what we do.
And got the chance to see a medieval contraption in action this afternoon. And there it goes. VMI cadets launched a trebuchet to kick off National Engineering Week. They loaded up the device with 3-pound water jugs and launched them across the parade grounds. It was part of a lab for an engineering class. Cadets say it's a unique way to see engineering principles in action. And it's got the chance.
Okay, that's it. If you guys have any questions.
So, back to your initial part, what's the best, or can you list the good methods to determine the soil stiffness for pile or pipe capacity? I'm talking about like pressure meter, DMT, or any other methods that we may have in the field.
Be honest, I have not found background on the behavior of the foundation versus soil interaction. But if I assume they're going to behave similar to the pipeline, I think the most important parameters that you may want to think about is going to be the strain changes or the strain rate, and when it hits the when it hits the peak. So I believe in the foundation most frequently used the failure criteria that you have used in the field is going to be 9% criteria. So using the 90% criteria, find out what the strain is going to be, and then you may want to correlate the strain with your soil behavior, and then that's going to be how you're going to find out your Young's modulus of your soil. That's what I can recommend for now.
Okay.
And your,
Hi, it was a good presentation. What I wanted to check, have you come across a situation where part of the pipe is supported on a rigid foundation, maybe on pile foundation? For example, a multi-story building which is on pile foundation, and once the pipe is coming out, it goes to the soil with a very low modulus of subgrade reaction. So how does this differential thing is taken care?
Or in that case, we probably you may want to come up with the how the behavior is going to be changed as a function of depth. In my case, I was looking at this depth, but if you have some kind of a very important building right next to you, then you may want to define your depth in this way. So depends on the depth. Then you can use this kind of a design chart to approximate how much of the maximum force is going to be exerted into the pipeline right next to you. Any other questions? Well, thank you very much.